When talking about distributions, the place to start is where everybody starts, and that's with the normal distribution. The normal distribution is often also referred to as the Gaussian, or the Laplace-Gauss distribution. It is one of the most commonly used distributions, or not so much used, but occurring. It's used very often in science and social science, and this is mainly due to the central limit theorem. The central limit theorem states when independent random variables are added, their normalized sum tends towards a normal distribution. And another way of saying it is, or another property of it is, sampling distribution created using sample means approaches a normal distribution as the sample gets larger, no matter what the shape of the original population distribution. Now, the central limit theorem brings up the normal distribution a lot in science and math, well, specifically in science, because scientists do experiments and they do measurements. When you're taking these measurements, there's always some type of error in the tool you're using to measure. So when you get results from measuring something, you're adding the result with the error you have. So generally, when you add the things together, the normalized sum tends towards a normal distribution. So in lots of scientific experiments and social science experiments, the normal distribution pops up a lot. In civil engineering, it comes up in the compressive strength of concrete strength, vehicle speeds, turbulent flow, and the cohesive strength of soil. So you'll use these particularly in structural engineering, transportation engineering, water resource engineering, and geotechnical engineering. So the normal distribution is a probability density function, is a continuous function, and it is given the probability density function is given specifically by this equation, where sigma is the standard deviation and mu is the mean. It is the common bell curve that you're used to seeing in any high school introduction to statistics course, or you understand it because you understand that you want your grade curved, and to curve a grade, professors always use the bell curve. The cumulative distribution function is given here. The one unique thing about this function is that it includes the error function. The error function is a complex function of a complex variable. In statistics, the probability a random variable lies between -x and x for a normal distribution with a mean 0 and a standard deviation of 0.5. This is a function that you can just implement or look up and implement. It's a given. Now, normal distributions are nice because there's a bunch of things that you can automatically get from a normal distribution, and one of these things is a 3 sigma rule, or the 68, 95, and 99 rule. What this rule is, it says based on the number of standard deviations away from the mean, so the tip of the curve is the mean, and for a normal distribution, the mean and the mode are the same number. For each standard deviation away, you know that a certain percentage of the distribution lies in that area. So at 1 standard deviation away, we have contained 68% of the distribution. So I'm going to say sigma equals 1. At 2 standard deviations away, sigma equals 2. We've encompassed 95% of the distribution. And if I draw in sigma equals 2 and sigma equals 3, at sigma equals 3, we have 99% of the distribution. So that is the 3 sigma rule. It is very convenient in understanding what your probability of occurrence is. So if we have 3 standard deviations of the normal curve, that will basically give you a probability of 99.9%, or 99.7, I'm sorry. So one thing that has been done, because normal distributions are so common, and before we had computers to do statistics work for us, we had to do everything by hand. One thing that is a great tool is the standard normal distribution. So The standard normal distribution allows you to take any normal distribution and turn it into a standard distribution with a mean at 0 and a standard deviation of 1. What this lets you do is to create tables for the normal distribution that you can use in determining probabilities and doing calculations. So when you have a mean of 0 and a standard deviation of 1, the PDF, or probability density function for normal distribution, simplifies. Once you have this, you can relate any normal distribution to a standard normal distribution by taking the random variable x, subtracting the mean and dividing by the standard deviation. This is the z-value, or the z-score. And once you compute the z-score, you can use tables to calculate the area under a normal curve. So here on the rows, you have your z-score. And over here on the top, you have your probability. And you can look up anything. Let's say if you have a z-score of 0.3 and you want to know a probability of 99, you would find that it is 0.62 on your standard normal curve. And this is giving you the probability of something being less than your z-value. Okay? You can find different tables that give you the left-hand side as well. These will all be less than 0.5. Here you see this table starts at 0.5 and goes up. You can also find ones that tell you from the middle out. There are all types of different tables, and they'll generally have a figure at the top like this that shows you what they represent. Now, in general, the hand calculations and things that go along with the probability aren't used, but this use of the z-score and standard normal tables becomes really important when you're taking standardized tests like your FE exam.